A 4,000-year-old meal was found completely intact. The noodles were still in the bowl. And that is only one of 12 noodles with a story you would not expect. 12 noodles, one complete breakdown.
Lo mein is not a dish. The name does not describe an ingredient, a dough, or a recipe. It describes an action, and that distinction changes everything. The dough itself is a standard wheat matrix, often enriched with egg for structural integrity. But its true defining characteristic is how it is handled post-boiling. Instead of sitting in a broth where it would continue to absorb liquid and degrade, it is removed and vigorously mixed with a heavy oil-based sauce. The oil coats the exterior of each strand. This creates a hydrophobic barrier, preventing the noodles from clumping and preserving their chewy texture. It is a method of moisture control disguised as a flavor profile.
Udon relies on the physics of extreme gluten development. The dough requires such a high ratio of salt and so little water that kneading it by hand is nearly impossible. Traditionally, bakers place the dough in a thick plastic bag and repeatedly stomp on it with their feet. The heavy, rhythmic pressure forces the wheat proteins to align and form an incredibly dense, highly elastic network. When boiled, this fixed strand expands, but the tightly woven gluten prevents it from falling apart. The result is a thick, pale white noodle with immense structural resistance. The texture is not a byproduct of the ingredients, it is a direct result of blunt mechanical force. While udon relies entirely on hyperelastic gluten, soba operates on the exact opposite principle. Pure buckwheat contains zero gluten. It lacks the elastic proteins necessary to bind a dough together. Historically grown in harsh mountainous climates where wheat failed, buckwheat was a survival crop that defied standard baking. To force it into a noodle format, makers must use a highly specialized technique, rapidly mixing the flour with precisely measured boiling water to gelatinize the starches. This fleeting chemical reaction acts as a temporary binder. Even then, the dough is incredibly fragile and prone to shattering. It is a masterclass in forcing an uncooperative grain into a continuous strand.
Ramen is not defined by its wavy shape, its origin, or the broth it sits in. It is defined purely by chemistry. The dough requires the addition of Kansui, a highly alkaline solution of potassium carbonate and sodium carbonate. This chemical additive drastically raises the pH level of the dough. The high alkalinity alters the structure of the wheat gluten, tightening the network and giving the noodle its characteristic firm, snappy bite. It also reacts with naturally occurring flavonoids in the flour, turning the strands bright yellow without the use of eggs. A noodle without Kansui is just boiled wheat. Chemistry separates it from the rest.
Remove gluten from a noodle, and the entire structure collapses. Rice noodles solve that problem, without gluten, without kneading, and without a single minute of resting dough. The architecture relies entirely on rapid starch gelatinization. A wet batter of milled rice and water is spread paper-thin over a cloth suspended above boiling water. Intense steam hits the batter, instantly cooking the starches and locking them into a translucent, flexible sheet. The sheet is then cooled, oiled, and sliced into ribbons. The entire process takes seconds. It is a structure built entirely by steam. Introducing animal protein into a wheat matrix changes how the dough reacts to heat. Egg noodles incorporate both the yolk and the white, adding fat, protein, and emulsifiers to the flour. The lipids coat the gluten strands, making the dough richer and slightly tender. More importantly, the egg proteins coagulate when the noodle hits boiling water. This creates an internal structural scaffolding that sets immediately under high heat. It raises the boiling threshold, preventing the noodle from dissolving into mush, even if overcooked. The egg does not just add color, it acts as an internal thermal shield. Vermicelli was engineered for extreme conditions. Spun into ultra-fine hair-like white threads, Each strand is engineered for maximum surface exposure. This geometry serves two critical purposes. First, it allows the noodles to dry almost instantly in the sun, stripping away the moisture that causes spoilage and making them highly resistant to rot during long trade journeys. Second, it turns them into an early form of instant food. The thin strands rehydrate and cook in mere seconds when submerged in hot water or broth. They were built for preservation and speed, centuries before modern processing.
1. That is often how many noodles are in a traditional bowl. Biang noodles defy standard extrusion or cutting methods. They take the form of massive, wide, belt-like strips of dough. The preparation requires a baker to repeatedly slap a single thick piece of heavily oiled dough against a wooden table, stretching it outward with each impact. The oil prevents the dough from tearing, while the aggressive slapping rapidly develops the gluten into a long, continuous ribbon. A single strand can easily exceed 3 feet in length, filling an entire serving bowl. It is a physical spectacle turned into a meal.
Somen noodles represent the extreme limits of physical stretching. Unlike cut noodles, somen is elongated through a continuous, painstaking process of pulling. The dough is stretched so thin, often less than 1.3 millimeters in diameter, that the tension threatens to snap the strands. To prevent this, the dough is heavily coated in vegetable oil during the pulling process. The oil lubricates the surface, allowing the strands to slide against each other without sticking, while also locking in residual moisture so the dough does not dry out and break. It is a delicate balance of tension and lubrication.
Yimen does not begin as noodle dough. It begins as a fryer. After the dough is formed into strands, it is submerged in hot oil and deep fried before drying. The frying process drives out internal moisture, replacing it with oil. This creates a porous, sponge-like internal structure sealed by a thin lipid barrier on the exterior. The result is a noodle that is shelf-stable without refrigeration and rehydrates almost instantly when submerged in hot broth, because the pores that once held oil now draw in liquid. The technique originated in Guangdong, likely during the Qing dynasty, and became a staple of Cantonese banquet cuisine. It is served at weddings and birthdays specifically because its length, the strands are never cut, symbolizes longevity. A noodle engineered for preservation, celebrated for what it represents, not what it contains.
Glass noodles completely abandon the use of flour. They are made entirely from isolated starches extracted from mung beans, sweet potatoes, or tapioca. By removing all proteins and fibers, the makers created dough of pure carbohydrate. When extruded into boiling water, the starch molecules instantly gelatinize in a line, turning completely transparent. Upon cooling, they form glassy, gelatinous threads that are highly resilient. Because they lack internal flavor compounds, they act as transparent liquid sponges, absorbing any broth or sauce they touch. They are less of a carbohydrate base and more of a delivery mechanism for external flavors. Shirataki changes the biological purpose of eating. Made from the corm of the konjac yam, these translucent, gelatinous bundles consist of 97% water and 3% glucomannan, a highly viscous dietary fiber. Because the human body lacks the enzymes to break down glucomannan, the noodle contains virtually 0 calories. It passes entirely through the human digestive system unchanged. It provides the mechanical sensation of chewing and swallowing a heavy carbohydrate, but delivers no energy to the body. It is an edible illusion, a food designed to be consumed, but never absorbed.
In 2005, archaeologists excavating the La Ya site in northwestern China made an unprecedented discovery. They found an overturned clay bowl buried deep under sediment left by a catastrophic earthquake and subsequent flooding. Preserved in the vacuum beneath the bowl was a bundle of thin, yellow noodles.
Scientific analysis revealed they were made from broomcorn and foxtail millet, dating back 4,000 years. They are the oldest noodles ever discovered, proving that the technology of extruding dough existed millennia before previously thought. A daily meal, preserved by a catastrophe, found 4,000 years later, still in the bowl.